So we're going to continue with more trigonometric equation. Okay, so for the first case, we're going to solve the trigonometric equation using trigonometric identity. Okay, if I have 1 plus sine x equal 2 cosine square x, so cosine square x, I can rewrite it as 1 minus sine square x. Right? So if you recall the Pythagorean theorem, I have sine square x plus cosine square x equal 1. Right? I wanna solve for cosine square x. So cosine square x is equal to 1 minus sine square x. Now, why do I want to do this? Because on the left hand side, I have sine x, right? On the right hand side, I have cosine square x. Nothing I can do if I leave cosine square x like that, right? So one way I can do is I can switch it into sine square x, and then from there I see the quadratic equation, right? Quadratic function in form, and then we're gonna factor it out, and we can solve for x. You can solve for x for the next step, right? So here I have 1 plus sine x on the left hand side. For the right hand side, I'm going to substitute cosine square x with 1 minus sine square x. All right. So on the left hand side, I'm just rewriting this. The right hand side, I'm going to distribute the 2's. So I have 2 minus 2 sine square x. Move everything to the left hand side. Okay, move everything to the left hand side. So I have 2 sine square x, and rearrange it in descending order. So 2 sine square x plus sine x minus 1 equals 0. Negative 2 plus 1 is minus 1. Now I see quadratic in form, right? Quadratic form. So if you factor this, if you're uncomfortable leaving like this to be factored, you can let y equal sine x like we did before in the previous video, right? In previous video, I let y equal cosine x, and then y squared equal cosine square x. But I'm gonna leave for this one, I'm gonna leave it like this and factor. Okay. So I need sine x here and then sine x here, because 2 sine x times sine x give me 2 sine square x. Right, and then I need 2 number multiplied to give me negative 1. Okay. So the only possibility is either minus 1 and positive 1. Okay. So if you double check, negative 1 times 1 is negative 1. Positive 2 sine x minus sine x is positive sine x. So we're good. So from here I have either 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. So add 1 and divide it by 2, I have sine x equal 1/2. And down here I have sine x equal negative 1. If you look at the unit circle, where sine x equal 1/2? Well, sine x equal 1/2 when x equal either pi over 6 or 5 pi over 6, right? If you look up on unit circle, and again, because this is the unrestricted domain, and we do it in side terms, so you have to add 2k pi at the end. Okay, why? Because the period of a sine function is 2k pi, right? Where k is integer, set of integer. Okay. And down here I have sine x equal negative 1. So again, you look at the unit circles. The angle that give me sine x equal negative 1 is x equal 3 pi half. Right? That's the only possibility. And again, we're gonna add 2k pi at the end. So these are my solution. Okay, so second example, I have sine 2x minus cosine x equals 0, right? So for this one, if you recall, one of the trig identity is sine 2x equal to sine x cosine x. Why am I using this one? Because at the second term, I see cosine x there, right? I can factor it out if I switch side, if I'm using this identity, right? So instead of sine 2x, I'm gonna write it as 2 sine x cosine x, right? Minus cosine x equals 0. And now I can factor out cosine x. Okay? So cosine x times quantity of 2 sine x minus 1 equals 0. So you have either cosine x equals 0 or 2 sine x minus 1 equals 0. On the unit circle, where's cosine x equals 0? Well, either x equal pi half or 3 pi half, right? And then you add 2k pi. 2k pi. Okay. The second one, I'm going to add 1 divided by 2. So sine x equal 1/2. Right, sine x equal 1/2 on unit circle. So this one right here imply x equal either pi over 6 or 5 pi over 6. Right? And we add 2k pi at the end. Okay, so those are our solution. Okay. So it takes practice to see the form of the equation that you do it. Okay, I did not know in the top of my head when I just eyeball it, right? It just take me a lot of practice and homework. When you see something, you just kind of know. Right? All right. Okay, so for the second case, we're going to solve trig equation involving multiple of angles. So far, we only did what? We only did the single angle, right? So theta equals something, right? Or x equals something. Now we're going to have multiple angles. So we're going to have, so for the angle that next to the function is no longer single. And so for example, solving 2 sine 3x minus 1 equals 0. This one is a comma right here, typo. Sorry about that. And for part A, they want you to find the solution in the interval from 0 to 2 pi. So this is the restricted domain one, right? But so just let's solve. So let's solve for x. So I have 2 sine 3x minus 1 equals 0. So add 1 both sides. I have 2 sine 3x equal 1. Divide both sides by 2. Sine 3x equal 1/2. Okay, always isolate the function first, right? Okay, so if you look at the unit circle, where is sine of 3x equal 1/2? Right? So if you're uncomfortable, you can view that the 3x at theta, right? So where sine of theta equal 1/2. So so the sine theta equal 1/2 where either theta, which is 3x, equal to pi over 6, or 3x equal 5 pi over 6. Okay. And if you solve for this, x equal times both sides by 1/3, so pi over 18, and x equal 5 pi over 18. Okay. So those are the solution for part A. Now part B is they want you to find all the solutions, meaning with unrestricted domain, right? So we solve the equation above, and we see that we at the almost at the end, we see that 3x equal pi over 6, and 3x, because that's my angles, right? That's my angle, equal 5 pi over 6. And because this is the psi function, what we're gonna do is we're gonna add 2k pi at the end. Remember what we talked about that in the previous video, right? Because the period of psi or cosine is 2k pi, right? Where k is just integer number, like 0, 1, 2, 3, 4, or -1, -2, -3, etc. Okay, so this is, so if I add 2k pi, and now I'm going to solve for x. Okay. So if I want to solve for x, I'm going to multiply both sides by 1/3 divided by 3. Okay. Okay, so if I do that, what do I have? Oops, I'm going to keep it red. I have either x equal pi over 18 plus 2k pi over 3, or x equal 5 pi over 18 plus 2k pi over 3. Oops, sorry. One of the mistakes that I see students make is that they solve for x first, and then they add the 2k pi later. So for example, if you solve for x first and then you add 2k pi here for the general solution, that is not correct. Okay, because your angle here is 3x. It's no longer just x. So okay. All right. Second one. So second one, the last one. Find all the solution of the function √3 tangent 3 theta minus 1 equals 0. Remember, the minus 1 here is not belong to tangent 3 theta. Okay, because they don't have the parenthesis. They don't have parentheses like that, right? So it's just all by itself. So for this one right here, first thing first, I'm going to add 1. Right, so √3 times tangent 3 theta equal 1. Divide both sides by square root of 3. Right, so if I divide both sides by square root of 3, I have tangent 3 theta equal 1 over square root of 3. Right. So again, where tangent of 3 theta equal 1 over square root of 3. So again, this is your whole angle right there. Right. So if you look at the unit circle, remember tangent is equal 1 over square root of 3. So it's a positive value. So you want to look at the first quadrant and the third quadrant, right? So first quadrant, I see pi over 6 and 7 pi over 6, right? I think we did this before. So these two right here. So pi over 6 and 7 pi over 6. Oops. Pi over 6. So I have 3 theta equal pi over 6, or 3 theta equal 7 pi over 6. And again, they want to find all the solution. So you have to add the period of, so you have to add k pi at the end. And because the tangent is periods is k pi, whereas k is integer, right? So I'm going to add k pi here, add k pi here. And now I'm going to solve for theta. So theta equal, multiply both sides by 1/3. Theta equal pi over 18 plus k pi over 3. or theta equal 7 pi over 18 plus k pi over 3, where k is the set of integer. Okay, so those are my solutions. Okay. Right, so that's how we solve in trigonometric equation with multiple of angle. Okay. Thank you for watching.